Welcome to this is Magic. We're learning things together as magical. Let's do question 39. Question 39. You have a car. It has a mass of 800 kilograms. It's inclined at 5 degrees. And you have a total distance of where it moves to be around 450 meters. The car starts from rest. So U is equal to 0. And travels upwards along a straight line, inclined angle of 5 degrees. Okay, 5 degrees for all of that is greater than bigger than 9. The length of the road is 450 meters. 450 meters. And the car has a mass of 800 kilograms. The speed of the car increases at constant rate. So speed increases at constant rate. And it's 28 meters per second at the top of the slope. So V is equal to 28 meters per second. A, determine for this car traveling on the slope its acceleration. So A1, you define the acceleration. So let's draw the UV set line. So the UV and set line, U equal to 0, V is equal to 28 meters per second. As here, equal to 450 meters. We want to find acceleration. We already have 3. We don't need T. So what's the equation that has USAV, which is the fifth equation? V squared equal to U squared plus 2NS. This one is equal to 0 because it starts at rest. And we want to find A. So A is equal to V squared over 2S. V here is 28 squared over 2. S here is 450. So, this is calculated. I would bet by the time you unpause this video, you should get a value of around 0.87 meters per second squared. Moving on to the next part, which is they want us to find the time taken to travel the length of the slope. So you want to find time. Again, just now we find A, so now we want time. We're going to use the same UV set line, this time T. So which equation has U as V and T? And which equation could this be? Okay. We don't want acceleration, so the only equation that has is equation 1, which is S is equal to U plus V over 2 times time. You see this as O level as average velocity times time. In this case, we want time, so it will be equal to 2S over U plus V. S here is equal to 450 meters. U is 0. V is 28. So, use your calculator. Hopefully, when I pause this video, you should have around 32 seconds. Then we move to the third one. You want to find the gain in kinetic energy. Delta EK is equal to half and delta V squared. It just means half and V squared minus U squared. In this case, your M is 800 kilograms. V is 28 squared minus 0 squared. So, again, this is your calculator. By the time you unpause this video, you should get a value of around 3.14 times 10 to the 5 joules. Then we move on to the next question. The next question here is the gain in gravitational potential energy for delta EGP equal to mg delta H. So we need to find the height in this question. We already got right angle triangle. This is your opal, which is your height, and 450 meters is actually your hippo. So we're dealing with sine theta. So sine theta is equal to oppo over hippo. Oppo is your height over 450 times equal to sine 5 degrees. Therefore, h is equal to 450 times sine 5 degrees. So, using this equation, delta EGP is equal to 800, your mass, times g, 9.81, times the delta h, which is 450 times sine 5 degrees. Please use a calculator. Hopefully by the time you pause this video, you should get around 3.07 and 10 to the 5 joules. Then we go to B, use your answers in A. To determine the useful output power of the car. So you define useful output power. P useful, what is it equal to? Remember the equations of power for non-electricity, these non-electric power equations. Work done over time is equal to energy over time between the work done equal to force times velocity. In this case, our velocity is changing. We have delta EK, delta EGP, and we need to find our useful power. So our useful power in this case should be, if you look at this, is it your kinetic energy? Is it your EGP? Which one could be the answer to this question? What are you actually doing here? From 0 to 28, that means there is increase in kinetic energy, but at the same time, you're also going against gravity. That means, using this equation, what is your E total over here equal to? Your E total is your EGP plus your EK over the time taken. And what is the time taken here on the board? You notice is the 2 seconds. So, EGP here is 3.47 plus EK here is 3.14 times 10 to the 5 over time 22 seconds. Once again, we have a calculator, so please calculate this. Hopefully by the time you unpause this video, you should have a value of 1.93 times 10 to the 4 watts. So for every second, you have 1.93 times 10 to the 4 joules that is used every second until you reach a maximum in the 2 seconds of this value. That is what is the difference between power and electricity. One gives you the rate, the other one gives you just the total value. C. Suggest one reason why the actual power output of a car engine is greater than that calculated in B. They say with this calculation, why is your real power that is used going to be greater than 1.93? Where we have calculated that it only requires this much to go against, to speed up and to go against height. And most of you have seen this again and again. Now this is another, you see it once again, the solution is quite simple. You have some work also done against frictional forces, meaning you have friction against frictional forces. Okay, in this case you have a lot of different types. You can have friction against the road or air resistance. So you can mention frictional forces could be vehicle against air resistance. distance, or it can be wheels and rope. Literally, you have friction between your wheels and your rope. Okay, I hope you understand this video. If not, please repeat.